All right, so yesterday we had done the left-hand sum and the right-hand sum, and so that was what was in these two graphs here. So then you still had one graph left over if you happen to write on that graph. There's extras at the front. So the next two, there's two more, but you just need that one extra graph. So the next type is the midpoint sum, and a midpoint sum won't work for this distribution, but I want to show you why. So a midpoint sum, we know that the right-hand sum, all of these points had to be the right-hand corner of each of the rectangles, right? So we had that your right-hand sum was an overestimation, okay, with this data. So all of these, with it being your right hand, you had all of those rectangles, and so we took all of those areas, we summed them, and we got an overestimation. And then the left-hand sum was similar to that, but then each of these was the left-hand spot, so then these were inscribed rectangles, and so those were an under approximation. Okay, so then the next one is a midpoint, and so a midpoint means that each of these, okay, we have to divide into sections so that we could use one of them as a midpoint. And so by the definition of midpoint, we need to be in the middle. So we know that we have 1, 2, 3, 4, 5, 6 data points. And so in order to make a midpoint, we would say, okay, well, I can make a rectangle from these three, and then this one at 20 would be my midpoint. So I'd say, okay, make that the height then, because that's the midpoint. And then that would be a rectangle. Okay, then my next three would be these. So this one at 60 would be my midpoint. So that would be my next rectangle. And then my last one, I have two left. And so I can't take a midpoint of these. So I can't do a midpoint sum here unless I had, an extra data point up here, and then this guy could be my midpoint. So my midpoint sum doesn't make sense with this data, specifically because there are 6 data points. So in order to use a midpoint, you need a distribution where you have an odd number of points. So midpoint doesn't work with this, but we'll go back to what midpoint is. So with your last graph, okay, so our midpoint doesn't work, so if you wrote that in pencil, you can just erase that and use this graph now. So for the last one, so there's right-hand sum, left-hand sum, midpoint, and then the last one is trapezoidal. So your trapezoidal is a fun word, and just like it sounds, you use trapezoids. Okay, so a trapezoid, if you remember from geometry, has 4 sides, and 2 of the sides must be parallel. Okay, they don't need to be the same length, but they do need to be parallel. Okay, and then the other 2 sides can do anything they want. So one could be perpendicular, and then one could be connected this way, or you could have 2 sides, and maybe the 2 ends might both go out like that. That's a trapezoid. Or one can go in like this and one can go out. As long as you have 2 sides that are parallel and then your 2 other sides that make it a quadrilateral, that is a trapezoid. So if we're going to use trapezoids here, we would see, okay, to make parallel lines, we know that all of these lines here would be parallel, right? Because that's how we make a Cartesian plane. So all of these are parallel, so that could be our base. So if we turn it like this, that could be one of the bases and that's the other base, that it's parallel. And then I could connect it here, right? And then to do my last side, I would connect these 2 points, and so that would be my trapezoid. Okay, so that's my first trapezoid, so let's just focus on that one. So to find the area of a trapezoid, your area of a rectangle is base times height. Well, here we actually have 2 bases. The lengths of the bases are not the same. So you take your average base. So you take your 2 bases and divide by 2. Okay, the sum of your 2 bases, and then divide by 2. And then you say, okay, so that's my average base length times your height. Okay, so that's the area of a trapezoid. Okay, so just to remind yourself of that from geometry. So then if I am here, okay, my trapezoid, I will find the area of each of these. So before you draw in all of the other trapezoids, let's just talk about the area of just this one here. So if you would like to, you can look at it this way if this makes you happier. So this is one of your bases, this is your other base, this is going to be your height. Okay, so if we find our area here, we know then that our area is base 1 plus base 2 divided by 2, and then times our height. Okay, so my base 1 will be this length, and so that's 100, plus my base 2 at 80, that was 50.4. And that was from our data from before with the US distribution. And then you divide that by 2, and then times our height. And our height is this length here, so between 100 and 80, so that's 20. Okay, so then that would be the area of that trapezoid. And so the area of this one here is 1,504. Okay, so then you do that with each of your intervals. So you need to make the next trapezoid would be here to here, and then your straight line to there. Okay, and then straight line to there. You have a trapezoid there. Next trapezoid is here. And then your last trapezoid is actually going to be a triangle, not a trapezoid, because this base height or length, however you want to look at that, is 0 because it's at 0, 0. So you could still use your trapezoid area, but your base 1 would be this height here. Your base 2 would just be 0. So you're essentially just taking the area of a triangle. So that's how you do your trapezoidal. So go ahead and find all of your areas there. Okay, so that'll take you a little bit. So practice actually doing your trapezoid formula because it has been a while since geometry. So just pause the video, find your areas of your trapezoids, and then check with your partners to see if you've gotten that right area, and then check back to get the answer. All right, so the areas for these, this is 778. This one's 399. This one was 161. And this one was 36. So if you had taken those areas correctly, that would be each of the trapezoids. So then your total estimated area for the area under this curve, okay, is 2,878 units squared. Okay, so that's your approximation. Okay, so that's your trapezoidal. All right, so on your US distribution, you were able to do a left-hand sum, a right-hand sum, and a trapezoidal. The one that we couldn't do was the midpoint. Okay, so, and remember that we could not do the midpoint because of the amount of data points we had. So we only had 6 data points. If we had a 7th data point, we would have been able to make this a midpoint and have drawn in another rectangle. So it just depends on what your data looks like. If you don't have an odd number of points, then your midpoint doesn't make a good estimation because you can't include all of your data. So let's do a midpoint sum. Okay, so I'll have to give you new data just so that you can practice one. So midpoint sum, we are going to use this data here. So this was my illustration for this, why this did not work, because I drew this side in saying, oh, it doesn't work because we don't have odd. So that's why we need this new example. So here's your example. So you need to estimate the area under the curve, which is h of x. It says using a midpoint. Okay, that's where what that says off the screen. Sum with 3 subintervals. Okay, so pause that so you can write out this problem. Okay, so you're given your t and your h of t. So your first step is just to draw this. Okay, so you would sketch your graph. Okay? And then it says using midpoint. Okay? So I'm going to show you the graph that you would sketch. So as long as you have, a rough graph, you'll be fine. So in this one, we have 1, 2, 3, 4, 5, 6, 7 data points. So we know that midpoint is going to work because we do need an odd amount of data points in order to use the midpoint of each. So we look at our data. So we start at 2. So I would use these 3 data points as my first one. So this is my midpoint. So that would be the midpoint of these first 3. So that's the height of my first rectangle. And then I look at the next 3, and that's the midpoint of my next 3. So that's the height of my next one. And then my last one is these 3 points. That's the middle one. So then again, that's the height of my last rectangle. So now I take that and I find the area of each of these guys. And they're just rectangles. So just good old base times height. And then I'll sum them up. So I just called them area 1, area 2, area 3. So A1, A2, A3. Okay, so then your base times height. So your area 1, your base is 4, and your height was 3.8, because we got that from our chart. Okay, the second one, so that was the first. The second one, the base is 4, and the height here at 8 is 9.6. So that's how I got that second one. And then my third one, again, my base is 4, and then my height at 12 is 15.2. So then I would have that. So then my estimated area would then be 114.4. Okay, so that would be your midpoint. So it just depends on what data you were given originally, if you can use midpoint or not, just because it needs to be an odd amount of data points. So you have your estimated area is 114.4 units squared. Okay, so those are your 4 numeric methods. So these are numeric methods of what they called. So right-hand sum, left-hand sum, midpoint, and trapezoidal. Okay, so you have a homework on this. It's very short. Okay, so it's at the front of the room. So I just typed it out because there weren't great data sets in the book. So grab one of these, and this is homework that will be due on Thursday. Okay, so make sure you grab that and start working on this tonight, and make sure that you watch the second lesson. So this was just to wrap up. So now actually watch the lesson for today.